So, in the discussion that we had yesterday, right? So we started talking about, we were discussing about the different approaches of LGD model development, right? And in regards to that, we talked about the foundation approach in yesterday's discussion. Right? So we talked about how is it that under the foundation approach, the LGD can be determined using the haircut approach, right? So one thing that we saw was that the haircut was nothing but it was the difference between the market value and the purchase price paid at the beginning, and it referred to the haircut of the collateral. It refers to the haircut of the exposure itself, as well as it talks about the haircut of the foreign currency mismatches. So one thing that we can clearly see is that the choice of the LGD that we have is a function, or it's dependent on the haircut that we have. So the question that comes out over here is that that if haircut is so important, right? So if haircut is so important, then how is it that this haircut is defined or determined? So how do we determine the haircut? So when we choose the haircut, what are the guidelines, or what would be the specific criteria of choosing the haircuts, right? So so what are, or how do we choose this a haircut? What are the criteria? What are the fields of making this choice? So what are the important criteria? So first is, so it is chosen in line with the supervisory haircut standards. By the supervisory haircut standards. Right, so this is the first field of choosing the haircuts, and this is chosen as the percentage. Right, so the next part that is also, so however, apart from choosing the supervisory figures, you can also choose the intern as per the internal standards. Right, so there are internal standards of choosing this haircut approach, right? The internal standards. Now similarly, however, when we are setting these internal standards, they have to be in line with the BCBS framework. So this is precisely what the overall, so this is what the overview of the choice is. So either you can use the supervisory haircut figures, which is proposed in the document, or they could also be done internally but aligned to the standards of the choice of haircut or haircut estimation, which is laid down in the BCBS standards, right? So the next part that comes out over here is that the internal. So this is how we would actually do the Basel LGD calculations under the foundation approach. But if we move from here, but our key focus or a very important part of our discussion would be focused on the statistical LGD model development, which is the AIRB, which is as per the AIRB or the advanced internal rating based approach, right? So this is something which we need to focus on, and over here the banks can settle their or bank can you develop their own models internally. So banks can develop their models internally using the statistical methods. Their models internally. Right. So this is precisely where, and this is where the statistical model development or the question of statistical model development comes into play, right? And this is the part which is most sought after these days, the statistical model development. So first of all, what we need to understand over here is what are the core statistical methods that we would require for developing LGD, and how is it that the LGD data can be framed. Right? So let's try to first frame the model under the AIRB approach, right? Now, first of all, let's define the loss given default model. So this is a definition which we have already done. We have talked about the several components of this particular model, right? We have talked about components like recovery. We have talked about components like net present value. We have talked about components like the exposure at default, right? So we'll now pull them together to compute or to find out a formulae for LGD. So LGD under the AIRB model, the AIRB approach, is defined as 1 minus the recovery rates. One minus the recovery rate. Now, when I talk about the recovery rates, so how do I define this recovery? So this is the recovery rate is nothing but the amount recovered from the EAD. divided by the total exposure at default, right? So if I do this into 100, so this will become the percentage of the recovery. Amount from EAD, right? So now the question that comes out is that how is it that, or how would we do this part? The amount recovered from EAD, how do we define this part? So if we are trying to define this part becomes your, yes. Okay. So Kiran has a question over here that, okay, and EAD is the total outstanding amount. Yes, Kiran, EAD is the total amount which is outstanding at the date of default, right? And you also have a rather interesting question over here that if a defaulter is defaulted on mortgage and the value of the house is doubled, the loan value, then yes, it becomes a profit for the bank. The bank sells it off at a market value, but obviously they do not pay it back to the you know, to the borrower, right? So the objective of LGD is, so if in such a case, if the bank can actually make a profit from the recovery, the bank would do that, right? Because of housing prices changes. So all the measures that they take is to prevent themselves from losses, not to stop them from making profits, right? So if they sell off the entire business, they sell off the house and they make it double after adjusting for the recovery cost, it's a profit for the bank, which the bank keeps back, right? So that is something important. Okay, so now the question that comes out over here is that amount received from EAD. How do I calculate that? So how do I, amount recovered from the EAD? So the recovery, how do I calculate? So let's start by discussing the calculation of the recovery. So recovery is defined something like this. So recovery is the EAD. So that is the total exposure at default, right? Now to this, I will add the net recovery. So from here, from this, I will recover some amount, right? And to this I will add some value. So what will I add? I will add the net present value for recovery costs. The recovery costs. Now the costs will increase the total EAD or the exposure to the of the bank minus NPV. So over here, this is the net present value of the recovery, right? So this is how you define your recovery. So your recovery is that you have the total exposure at default, which is the total exposure which is outstanding. Plus to that you add your net present value of the recoveries and the recovery costs. And from there you remove the net present value of the recovery, right? So the amount which could be recovered is the net. So the difference between the two will be your loss given default. So recovery is, or rather what I'm writing over here is the 1 minus recovery, right? And this is as a percentage of the exposure at default. So if I adjust this will become 1 minus summation net present value of recovery minus the net present value of the recovery cost. This whole divided by the exposure at default. Right? Okay, fine. Okay, let's say the total exposure is 100 rupees or 1,000 rupees. Okay, so from here, the next part that you have is the net present value of the recovered. So that is, let's say, 75. And to that, I also have the net present value of the recovery cost. Let's say this is 30 or 25. So what is the loss given default? So now I'm saying that okay, the loss given default is the total exposure that I had, EAD, is 1000, right? 1000. Now to this, while in the process of recovery, I added on 25 rupees as recovery cost, and I finally managed to recover 250. And I finally managed to recover 750. So the total amount that was recovered, the total amount that I managed to recover was, or the manage that I could not manage to recover was 500, right? So what was the loss given default? This as a percentage of the total exposure. So the exposure, also the LGD that I have over here is 0.5. Now in an LGD problem, when I'm trying to define the LGD, the exposure is given or it's observed. I know, okay, this record defaulted and this EAD over here was given. Given. So the predicted part is this. So the recovery is the predicted part. So the entire interest in an LGD model would be to predict the recovery. Okay. So Seva has a question over here. LGD is calculated portfolio account level. So LGD is calculated at an account level and then aggregated to report it at the portfolio, like the average LGD, right? Okay. So now the next question that comes out is the entire prediction or the entire game of prediction over here revolves around LGD. So when you're predicting, right, you predict it at always at an account level because the expected credit loss is predicted at an account level. So if you are trying to predict the recovery, you need to predict it at the recovery level. I mean at the account level. So for each account you obtain the recovery and hence the loss given default. Right? So now comes the question. So from the entire, so from the problem that we started, right, we've now boiled down to the point that whatever prediction has to be made is to be made regarding the recovery. Once it can predict the recovery, I'll get the recovery rate, and when I predict the recovery rate, I'll get my LGD, right? So the question now revolves around recovery. So, what are the two types of recovery? What are the different kinds of recoveries that can happen? So, this is where again the next part comes. So, the next important topic comes in, the type of recoveries. So, we have talked about two forms of recovery. One is uh, you know, your complete workout and the other is your incomplete workout basing on uh, the whether your recovery is completed or incomplete. Now this is based on the source of the recovery. Over here, when I talk about recoveries, recoveries are of two types: cash recoveries. Cash recoveries, and the other is the non-cash recoveries. Non-cash recoveries. So when basically when we talk about cash recoveries are more relevant for unsecured lendings. Unsecured lending, right? And over here, what we have is a non-cash recoveries is there for secured lending, right? So what is the non-cash recoveries? So this is non-cash recoveries actually happen in the form of repossession of assets. Repossession of assets. Right. So so now the so one very important thing that comes out is that this recovery becomes our dependent variable, right? Now when this recovery becomes my dependent variable, how do I, or what are the ways through which I can predict it, right? So what would be the equation that I would use to predict this LGD? And what are the different ways I can predict my LGD model? So basically the recovery, right, is a very simple continuous dependent variable. So now how do I define this recovery? Or how would I estimate this recovery? So the recovery will be equal to, so obviously if I write it in the form of a mathematical equation, it is intersect plus the recovery characteristics in the ith account plus the firm characteristics, or let's say if it's a individual, which we call it the behavioral characteristics, right, plus the impact of macroeconomic variables, if any, because the loss given default is impacted by the macroeconomic variables. By the macroeconomic variables, right? So this is something which we, so this is where, this is how this recovery model gets initiated. And if you look into this dependent variable, the way the dependent variable is defined over here, this dependent variable is continuous in nature, and therefore one of the models that we can actually use to predict this recovery is the linear regression model. But before we go ahead to do this, there are a few other things to understand, right? Because the distribution, so one major challenge in LGD models is the LGD distribution. The distribution of an LGD model is very different from any other models, right? Because one very important characteristic of this is that this is a very cornered distribution. So either you have a collect corner at 0, or you have a cornering at 1. So the LGD distribution is very different, and that is where you require other kinds of, so you need to find out different ways of working around with it. So this is the part that we will talk about in our discussion next. So the typical LGD distributions. So how does the LGD distribution look like, and how do you solve the problems associated with that distribution, right? Okay, so just give me a minute's time and we'll come back and we'll continue with this. Okay, so as I was saying, now coming back to this distribution. Now, one characteristic of the LGD distributions is that, just a minute. So one important characteristic of this binomial of the LGD distribution is that it is a bimodal distribution, right? Is a bimodal distribution. Now, why is this a bimodal distribution? Because one very important characteristic of a loss given default model is that either, so generally what happens is either the distribution is concentrated towards zero or it is concentrated towards one, right? Uh, so over here, let's say I'm trying to plot a LGD or a loss given default model, right? So over here, let's say it's zero, and over here I have the percentage of recovery, and over here I have the LGD. So this is zero and this is one. So one is that is nothing would be recovered. So a typical LGD distribution looks something like this. Then it's something like this. It goes on. So intermediate recovery is a very less frequency, and this is here again you have a large frequency. So one of the modes appear over here and one of the modes appear over here. So this is the bimodal frequency. The bimodal frequency, right? So if it is a bimodal distribution, right, and even if the LGD, the dependent variable is continuous in nature, but still developing a model using linear regression becomes difficult. Hence, a very important part of this would be the part of transformations. So, we need to understand the concept of transformations like box Cox transformations and so on. So, and similar methodologies to understand this LGD. So transformation. So over here we will talk about the box Cox transformations. Why do we need to make such transformations? What is the importance of such transformations and why do we need this in LGD model? So that is the next part that we talk about, right? So I'll take a pause here for the day. I will not move ahead. I'll start box Cox transformation and the concept of normality in LGD from the next from the next discussion. So we'll require two more sessions talking about the transformations, and then we'll spend like 2 to 3 sessions talking about the different modeling methodologies, and then we'll see how a model is developed, right? So that is going to be the next way to which we talk about, right? So thank you guys, thank you for your time, right? Let's take a pause here for the day. Enjoy of the remaining weekend, whatever is left, and we'll start off with the statistical portions from the next class, right? So thank you guys, thank you for your time, and let's catch up next week. So the next class is like similarly on Saturday and Sunday, 8 p.m. onwards. Thank you. Have a great week ahead. Bye bye.